Imagining a space voyage to an asteroid takes us back to the exciting scene in Star Wars, The Empire Strikes Back, where Han Solo skillfully pilots the Millennium Falcon, dodging huge rocks hundreds of meters across, until finally managing to hide inside one of these objects, giving his pursuers the slip. On the big screen, this dizzying succession of maneuvers took just a matter of minutes. In reality, landing on an asteroid is taking the OSIRIS-RX probe 2 years to carry out, in a complex and delicate mission that promises to give a boost to asteroid mining, a new stage in the space race that until recently seemed pure science fiction. This fast-paced adventure in scientific and astronomical terms began in 2016 when NASA launched the OSIRIS-RX probe to the asteroid Bennu, with the aim of landing on its surface, collecting samples and bringing them back to Earth for study. If all goes well, the happy ending on our planet will take place in 2023. For the moment, after 2 years of travel and another 2 years exploring the surface in detail, looking for the best place to touch down, there is now a planned landing date of August 25, 2020. Asteroids are remnants left over from the formation of the planets that swarm through interplanetary space. They are composed of smaller elements that have gradually clumped together, conglomerates of rock and dust held together by the slight force of their gravity. Their sizes range from a few kilometers in diameter to hundreds, as is the case with Bennu, to the 1,000 kilometers in diameter of Ceres, the largest asteroid we know of, although it also falls into the category of a dwarf planet. The majority of them are located in the area of the asteroid belt, orbiting the Sun between Mars and Jupiter, but these are not the only ones. There is another group, numbering at least 1,000, which orbits between Mars and the Earth and crosses the path of our planet, and may even collide with it. They are known as NEOs, near-Earth objects, and are monitored as dangerous bodies. Bennu is one of them, with a probability of 1 in 25,000 of colliding with the Earth in its approach of 2,135. Currently, it is about 600 times farther away than the Moon. The critical point of the mission will be reached when the probe slowly descends, lands on the surface of Bennu and literally vacuums up to 2 kilograms, minimum 60 g, of dust and small rocks from its surface. Because of the remoteness and the resulting delay in communications with Earth, the robot must do everything in automatic mode, and a small failure in any of the systems could result in OSIRIS-RX smashing into the asteroid, or being lost in space. In order not to leave anything to chance, rehearsals of the approach and departure are being carried out during these months. This is not the first time that a space probe has successfully landed on an asteroid to bring samples back to Earth. The Japanese Hayabusa probes were the first, but OSIRIS-RX is the most ambitious mission to date, because of its enormous scientific payload. Asteroids can be a strategic resource. On the one hand, they contain a large amount of water, which is crucial for the supply of future space missions, both as fuel. Water can be broken down into oxygen and hydrogen, which are the most common gasolines for spacecraft, and to keep the crew alive. On the other hand, asteroids can also be very attractive as a mining resource. During the formation of planets like the Earth, there is a moment when, due to the forces of compaction, and the effect of impacts and radioactive decay, they heat up and practically all their material becomes liquid. At that point, the mass of the planet is arranged by density. The heavier elements such as iron, lead and nickel fall towards the core, just like water and oil arrange themselves in a glass of water. This is why it is so difficult to find heavy and metallic elements on the surface of the Earth. Some of these very rare minerals are incredibly useful, especially technologically, which is why some, such as palladium, are actually more expensive than gold. This is the process known as planetary differentiation. It only happens on planets of a certain size, and it requires a significant mass for the process to take place. In asteroids it doesn't occur because they don't have enough mass to heat their materials to that point, and they also lack the gravity needed to move the elements to the interior. This is why it is much easier to find these precious elements on the surface of an asteroid than in the Earth's crust. Based on their composition, there are already estimates of how many billions of dollars each of these astronomical bodies could be worth. This is not science fiction. There are now space mining companies, such as Planetary Resources, which has already launched several mini-satellites to test several of its patents. Other companies like Asteroid Mining Corporation or Trans-Astronautica Corporation, although still far from their goal, are already attracting millions of dollars of private investment interested in being on the front line of a possible future space business. Is asteroid mining possible? This new space race already began back when the Hayabusa mission successfully returned a few grams of an asteroid's regolith, so the technology to harvest asteroid material exists, we just have to change the scale. It is no longer a technological problem. Is it economically viable? We are increasingly dependent on rare elements, such as those in the palladium group, which are expensive to exploit on Earth and come with a high environmental cost, so the sum of these two factors could make it profitable to travel to the asteroids to extract these raw materials. Astrophysicist Neil deGrasse argues that the planet's first trillionaire will undoubtedly be a space miner. So that is for today, guys. We'll see you in the next one. Tell me your thoughts in the comments. Like and subscribe. And always remember, we are still alive.